All right, guys, this is 8.2 quadratic functions, worksheet 2. Let's jump in and give it a try. We're going to read this scenario, look at the graph, interpret what's going on, and then we're going to answer the odds. Maybe some of the evens. We'll see how things are looking. Luis kicks a soccer ball. The graph below shows the height of the ball over time. So, x-axis is time in seconds. Notice, each box is not a second. Each two boxes is a second. 1 second, 2 seconds, 3 seconds, okay? And it goes to 4 seconds, but the graph ends right here. So keep that in mind. It's good to interpret your graph. The y-axis is the height of the ball in feet. Each two boxes is 10, so each box is 5. 5, 10, 15, 20, 25, 30, 35, 40, and so on, okay? So now we know exactly what x and y are. Let's take a look at number 1. The x-axis represents the number of what that have passed since Luis kicked the ball. We just mentioned that, the number of seconds that have passed. Okay? And you guys can answer this one because we just went over that. Number 3, the starting height of the ball. Starting height. This is a soccer ball, and here's where it started. That's 0 feet. It's not any height. It's right on the ground. It has not been kicked. Okay? Number 5, the ball returns to the ground after how many seconds in the air? So they kick the ball, time is going by, and the height is increasing. It reaches its highest point here. It falls back to the ground, and it returns to the ground where? Right here at 3 seconds. Okay, and number 7. What is a reasonable domain? Domain is x. And range is y, for this problem situation. Okay, whenever you are dealing with a continuous graph, it's connected, you're most likely dealing with this type of situation. I know it looks scary, it looks kind of weird, but all you're doing is you're listing the lowest x value in your graph, and then these little less than or equal than signs mean it includes every single point in between, all the minuscule fractional points in between, all the way to the highest x value. And same here for y. The very lowest y value all the way to the highest y value. Now, since x is time in seconds, we're talking about the lowest time value. The lowest time value is 0. The highest time value is 3. We don't need 4 because the ball didn't go that far. The ball hit the ground at 3. That is our domain. Now, since they used, technically you could use t here instead of x, but we know this is x. They may put answer choices with t, but we know the t and the x are basically the same thing, right? They even labeled this x-axis. So we're going to use x. For y, what is the lowest the height value? The lowest height it ever was, which is here and here, was 0 feet. The highest height that it ever was up here. We have to kind of guesstimate that. It was bigger than 35, it was smaller than 40, it's a little past the middle, I would say about 38. And if you say 37 or 39, that's probably fine too. There you go. That's domain and range. Let's go to the back. Engineer Eric has launched a model rocket from the Earth with an upward speed of 160 feet per second, which goes right here. They did that for us. The path of the rocket can be modeled by the equation below, and here's the equation below. Okay, now I can put that in my calculator, but I'm thinking in terms of y and x. Y equals negative 16 x squared plus 160 x. Okay? So let's go ahead and get rid of the old stuff. And let's go to my graph. And let's type in negative 16x squared plus 160x. Enter. Now, This doesn't help us very much. It's just a straight line. But this is not really a straight line. It's actually a big parabola, but we can't see it. I want to see it. So I'm going to go to my menu and change my window. The window is the screen. I want to change what's showing on the screen. So I go to 4. I really encourage you guys to get used to this. The better you know your calculator, the more helpful it's going to be for you. I want the whole thing to fit, the whole graph, as much as possible. So I'm going to go down to this one. Zoom to fit. It does a little thinking, and then it does that for me. Now, I'm even going to go further than that. I don't need negative values because there's no negative time in reality. And I don't need negative height values because the rocket's not going into the ground. So I'm going to go back to menu, go back to window, and change my window settings here. So I don't need a negative 10. I may just put -1, just so my lines, my axis isn't right up against the screen. I'll put like -1. Okay, I want my maximum to be a little bigger. I'm going to make that 15. For y, again, I want my minimum to be like -1. I don't want a bunch of negative numbers. And my max can be whatever it needs to be. I push enter. That's a lot better. We can see the whole rocket equation now. Okay, it makes sense to us. Okay, let's go ahead and use this, and let's graph this thing. Now this gives us a sketch, and honestly I showed you all this, but if you don't do all that, that's fine, because we need to go to the table to get the exact numbers. Control T, and I'm looking at my values. When X is 1, when my time is 1, I'm at 144. When my time is 2, I'm at 256, and so on. I want to follow and start, I want to try to find the highest point the rocket reached. And there it is. Because see, it gets bigger. 256, 336, 384, 400. Oh, right here it's getting smaller again. Okay, and also you can notice what I call the twins, the twin y values. 400 has no twin. That means this is the vertex, the maximum vertex. Okay, so when I plot that point, that's the middle of my graph. 5 seconds to the right and 400 feet up in the air. So 5 seconds to the right, 400 feet up in the air. Okay? If you're not sure about that, you can actually go to the Analyze Graph part of our menu. Go to Menu, Analyze Graph, find the maximum vertex, and I can just go over here, click, drag, and it gives it to me right there, 5, 400. Sorry, it got dark in the room. I have to go turn the light on. 5, 400. So there's a few different ways. We found it on the table. We found it by analyzing the graph. Okay, so that's the top. Okay, let's get a few other points. We have this point. We need to get some points here and here and so on. We know it's at 0, 0. Where does it hit the ground again? Let's get that point. So I'm going to go to Analyze Graph. So menu 6 for Analyze Graph. I want the 0. No, I don't want the first 0. I know it's already 0, 0. I want the last 0, the one over here. So I'm going to drag over to the left, click, drag over to the right, and then it pops up right there. Looks to me like 10, 0. So that's 10 seconds right here. Okay, I want to get a few middle points to get a nice graph. So I'm going to go back to my table, Control T, and let's go ahead and do 2, 256, and 8, 256. You see that? I was looking for 2 matching Y's. So 2, 256, and 8, 256. About right there. To me, that's enough to go ahead and get a decent sketch of my rocket. Try to make it look rounded and not like a V, but more like a U. It's a little hard. Okay, so that's a good graph. Now, you can complete the table. Everything I was looking at in the calculator screen is how you would complete the table. Just fill in a bunch of time values and feet values. In fact, the points that we used, 0, 0. You can put that in your table. 10, 0, and 5, 400. Those are all points you can put in your table. Let's answer some questions. What is a reasonable range? Range is y, which is up and down. The lowest it ever got, and we always set up range like that for these problems, the lowest it ever got is 0. The highest it ever got was my vertex, maximum vertex of 400. So that's my range. 13. How long will it take the rocket to reach 384 feet in height? Now, it actually hits 384 2 different times, but they most likely want the first time, right? They don't want it when it's falling back down. So let's go and find 384. Let's see if we can find 384. There's one. There's the first one, though. At 4 seconds, it first hits 384. And then at 6 seconds, it's falling back to 384. So if you want to, give all the answers, it first hits 384 at 4 seconds, and then again at 6 seconds. Number 15, how long will it take to reach the maximum height? We already answered that. At 5 seconds, it reaches the maximum height. What is the maximum height? We already said it's 400 feet. Oh, I gave you an even problem. Will the rocket go higher than 400 feet? Not this rocket. Once it hits 400, it starts falling back down to the ground. So there you go. Come in for tutoring or just ask us in class if you have more questions.